Welcome my students, welcome to my today's topic. Today we will be dealing with the geometry part. Okay, the chapter is angles. So geometry is a part of mathematics basically which deals with the properties of lines, points, surface and solids. Okay, so already we come across geometrical concepts in our day-to-day life. Okay, so at first to learn it we have to know that what is the plane. Okay, so a plane is basically a flat surface. Okay, so figures with flat surfaces are plane figures. Okay, so like rectangle, triangle. Okay, so where the figure is formed by three or more line segments. Okay, got it. So we have to take closed figures, not open. So if we are taking the figure of triangle, it is like looks like that. So it is the closed figure formed by three segments, 1 2 3. Okay, three line segments. Got it. So if you are taking rectangle, so it is also the closed figure with four line segments. Okay, and so on. But if we are taking the figure like that way, okay, so it is not the figure, closed figure. Okay, got it. So at first we will be learning about the point. Okay, so what is a point? A point is basically the smallest shape in geometry. Okay, that has no length, no breadth. Okay, so if you see here in this figure, you can see that here points are represented by capital letters here such as A, B, C, D. Okay, next one is line. What is line? Line is a straight figure having no end points. Okay, so a line is represented, so a line can be extended on both of the side. Okay, here we can represent a line by two capital letters. Okay, two capital letters such as here we are taking A, B. Okay, so the point A, B are selected to name the line. Okay, so the arrows on the both ends shows that the line can be extended to any length in both of the direction. Okay, so here the lines can be written as A, B and above it is the line. Okay, we can write like that way. Next one is ray. Ray is a part of a line with an originating point. Here you can see that only arrow is here in one hand or one direction. Okay, so here is the originating point. Okay, so it means that a ray has one fixed end point and it can extend to other directions endlessly here in this direction. Okay, so we can draw the ray like that way or in this direction, that means any direction with one fixed point. Okay, so the ray here is written as OP and as it is originating at point O and P here is another point taken to name the ray. Here at this point it can extend beyond P to any length, so we can write the ray as OP and above it is ray sign of ray. Okay, got it. So if you write line for line, we can write like that way, but for ray arrow will be only one direction and for line it will be on both direction. It is the difference. Okay, now it is line segment. Actually a line segment is a part of line which has two definite endpoints. Okay, got it. So here AB is the line, it can extend in on both of the directions. but here if we take this segment, it is known as the line segment. So AB here is the line segment, okay, having two definite endpoints. Here the point is A and B, so it cannot extend on the both of the direction, okay. So AB is a line segment here, so we can represent AB line segment like that way, with a bar without any arrows on any direction, okay, got it. So if you see that, it defines that AB is a line segment, got it. So what is the outcome? Outcome is line has no endpoints, ray has one endpoint, and line segment has two endpoints. Line has an infinite length, ray has infinite length in one direction only, and line segment has definite length, okay. In line, length cannot be measured, but in ray length cannot be measured also, but in line segment length can be measured, okay, got it. Next, that is the relation between points and lines. Number one is, you can see here in this figure, the first figure here, innumerable number of lines can be drawn through a point. So if you are having a point, you can draw infinite number of lines, okay. So in this figure lines AB, CD, RS, PQ pass through the same point, that is O here, so they are concurrent lines, okay. Number 2, in this figure, if 3 or more points lie in a straight line, here we can see that Q, R, S are the points lying on the same straight line, so that all these points are known as the collinear points, okay. So here Q, R, S are the collinear points since they lie on a straight line, got it. Next, number 3, the 3 points here you can see that which do not lie in the same straight line, here D, E and F are not situated on the same line, got it. So these points are known as the non-collinear point, and as A, B, C are the points which lie in the same straight line, they are known as the collinear points, okay. Next we will be dealing with parallel, perpendicular, intersecting lines and coplanar lines. At first, parallel lines. In the first figure you can see that two lines on a plane surface which never meet each other are called parallel lines, and here if you see that the distance is the same between the parallel lines, always remains same, okay. So in this figure, two lines will never meet because the distance between these two lines is the same at every point, so these two lines are parallel, okay. So if you give a name to the parallel lines, suppose the first one is A, B and it is C, D. So here both of the lines AB and CD are the straight line, and here are the parallel lines, because if we extend both of the lines, they cannot meet at any point, okay, because the distance between them at every point is the same, okay. So AB and CD here are the parallel lines. So if we represent this as the parallel, we can write AB, okay, parallel line with CD. So here it is AB parallel to CD, we can represent like that way, and here we can as AB is the straight line, we can mention the symbol here. Okay. So if you take the live example, if you see the railway tracks, the edges of ruler or scale and blackboard are the examples of parallel lines. Okay. So here you can see all the figures here are the example of parallel lines. Okay. But if you see this figure, you can see that PQ and RS are not parallel. Okay, because here you can see that the distance here is not same as the distance here. Okay, so if we extend this line, we can see that both of the lines meet at a point, so it is not the parallel lines. Okay, so here in this figure PQ and RS are not parallel lines. Okay, because they meet each other at the point here. Okay, next is intersecting lines. When two or more lines meet each other at a point, the lines are called intersecting lines. Here you can see that two lines here, suppose PA and QB are the lines. Okay, and intersect at a point O here. Okay, so the lines here PA and QB are called intersecting line. Okay, and they are meeting at a point O. So O here is known as the point of intersection. Okay, so the lines which are intersecting with each other, then they are known as the intersecting lines. Now next point is perpendicular line. When two lines, rays or line segments intersect each other at right angle, that is they form a 90-degree angle with each other, then the lines are called perpendicular lines. Okay, so here we are taking for the line segment lines and rays, and here the angles is 90-degree. Okay, so if you take, suppose it is XO and it is OI. Okay, and the angle is 90. So here rays OX and OY meet at point O and form an angle 90-degree at point O here. So OX and OX and OY are the perpendicular to each other, and if we represent it, we can say that as OX is the perpendicular on OY, then we can write OX and then perpendicular sign and then OY. Okay, so we can write OX then perpendicular sign then OY. Okay, got it? Okay, and last one is coplanar lines. If two lines lying on the same plane, here the lines N and M are lying on the same plane here, so that these two lines are known as the coplanar lines. Okay, but if they are not lying on the same plane, here you can see that line L are lying on another plane and line N is lying on the another plane. So these two lines are not coplanar lines here. So these are known as the screw lines or non-coplanar lines. Okay. Okay. Now we are dealing with angle. So you can see this figure. So two rays having common end point form an angle. Okay. Here we are taking two rays. One is OP, another one is OQ. Okay. And between these angle is made. Okay. So two rays having a common end point form an angle. So here is the common point is O. It is known as the vertex. So two rays here OP and OQ are meeting at a common point O. and the gap between OP and OQ, here it is known as the angle. Okay, and we can represent the angle like that way. Okay, got it? So now the next part is how to naming an angle. Number one is angle between rays, here it is OP and OQ, can be named as P can be named as POQ. You can write it, this is the angle sign, and then write POQ. So we have to write the point in the middle where the angle is situated. Okay. Number two is angle between OP and OQ also can be named as like that way, QOP. So here we can write POQ, or you can write on the opposite direction, that is QOP. But remember that O should be lie in the middle as it is the angle. Okay. So sometimes the angle is represented by small letters. We can write, give the name to the angle, suppose X, Y or Z. Then you can write that angle X like that way. We can rename like that way. So here in this figure you can see that these are the two arm. When joined at a fixed point, the space between them is known as the angle. So the two rays which form the angle are called the arms of the angle, and meeting point of two rays is called the vertex here. Here O is the vertex. Number one is rays OP and OQ are the arms of the angle. Number two, the meeting point O is the called the vertex. Okay. Now next point is interior and exterior of an angle. So an angle has three parts: interior, exterior and on the angle. So interior means when the points lying inside the angle form interior of the angle, and exterior means when the points lying outside the angle from the extension of the angle. Okay. So now check it. Suppose here look at the figure. Here the point, suppose we are taking ABC. So the point ABC here that lie inside the angle POQ. So these points are in the interior of angle POQ. Okay. Suppose if you take the point, suppose DEF that lie outside the angle POQ are in the exterior of angle POQ. Okay. And if we take the point G and H on the angle, suppose it is G and it is H, so the points lie on the angle that is POQ. Okay. Next is measuring an angle. So an angle is measured in degrees. Okay. So the symbol for degree is, you can write like that way. Okay. So the number of degrees of an angle is called measure. Okay. So here as you can see that the angle here, the measurement is 30 degree. Okay. So angle AOB here is equal to 30 degree. Here MON is 60 degree. Okay. Got it? Okay. So an angle is measured with the help of a protractor. This figure is the figure of protractor. It is the protractor. So angle is measured with the help of a protractor. A protractor has two scales. Angles from 0 to 180 are marked on the both scales here, and also you can go from this end to this end, two scales. This scale is inner scale. This scale is inner scale, 0 to 180 here, 0 to 180. This is the inner scale of this protractor, are marked anti-clockwise, and outer scale here 0 to 180 degree are marked clockwise. Okay, and you can see that the protector, as you can see that the protector is D-shaped. Okay, it is a part of instruments in a geometry box. Okay, now we are trying to measure an angle. Okay, suppose we are taking an angle O, P and Q it is. Okay, so at first match the center of the protector with the vertex, that is O here. We have to match the center here. Okay, with the line. Then move the protector to match the ray OP in one arm of the angle. The other arm OQ will be pointed towards one portion of the protector. Okay, now start counting 0 degree till you reach the other arm. Okay, so count the measure of the angle indicated on the protector. Here you can see that this line is going through the inner scale, that is 60. So the angle is 60. Okay, now we will be learning about the types of angles here. So angles are classified on the basics of their measure. So first one, you can see that it is acute angle. Okay, so what is acute angle? An angle which measures less than 90 degree is called an acute angle. So here you can see that the angle is 62 degree, so it is less than 90 degree, so that it is known as the acute angle. So if you give the example for acute angle, the angles may be 30, 45, 60, 80, 75. All these are the acute angle, as all these are the less than 90 degree angle. Okay, next one is right angle. So what is right angle? An angle which measures 90 degree is called a right angle. So here you can see that the measurement of the angle is 90 degree, so that it is the right angle. Okay, now next one is obtuse angle. So what is obtuse angle? The angle measuring more than 90 degree but less than 180 degree is an obtuse angle. So here you can see that the angle is 135 degree, so it is an obtuse angle because it is more than 90 but less than 180. So it should be more than 90 degree but less than 180 degree. It will be obtuse angle. Okay, so here 135 is an obtuse angle. Next one is straight angle. The angle which measure 180 degree, the angle which measure 180 degree is called a straight line. So here if you write the name ABC, so here angle ABC measures the angle 180 degree, so it is the straight line. Okay, next one is reflex angle. An angle more than 180 degree but less than 360 degree is called a reflex angle. Okay, so here this angle is known as the reflex angle since it is more than 180 and less than 360. So the angle is 240. So 240 is less than 360 but more than 180. So when the angle is more than 180 but less than 360 degree, then this angle is known as the reflex angle. Okay, now the last is complete angle. An angle which measures 360 degree is called a complete angle. So here as you can see that the angle measures 360, so it is the complete angle. Okay, so already we have learned about the types of an angles. Got it? Okay, now we are doing the construction of angles with the help of protractor. So example, suppose we have to construct angle x, y, z equal to 45 degree. Okay, so when we say angle x, y, z, that means the angle is formed by the arms x, y and y, z, and the vertex of the angle is y. Okay, so at first what to do? We have to draw a straight line, suppose y, z. Then we have to place the center of the protector at the vertex y. Okay, so we are adjusting the protector, like that way. So here you can see that adjuncts the protector in such a fashion that the baseline of the protector coincides with YZ here, okay, and then mark a point on X here at 45 of the protector here, okay, got it. Now draw a line with the point Y and point X at 45 degree, extends the lines. So here angle XY equal to 45 degree is formed. Similarly, any angle from 0 to 180 degree can be drawn with the help of the protector. So you will get the video lecture of this construction also. So if you have any problem at any point, so pause it and recap it. Okay, thank you very much.